Okay, in this video, I'm going to teach you several really important key things that your graphing calculator can help you do for an equation that you've graphed. So right now, the context that we're using this in is applications of regression, but I'm telling you that these features of your graphing calculator we are going to continue to use for the rest of the year. So really important stuff here. I've tried to be very specific about the steps you need to take, what you need to press in order to get your calculator to do all of these things. So to find when your function has a specific y value. So this might be, let's say, when does the rocket, this is from the last video's example, have a height and I can't remember, I can scroll back to the old notes to see. It's in meters. Okay, so have a height of 300 meters. So this is an example of why we would want to find when our function has a specific y value. So height is our y. We want to know, okay, when is the height 300 meters? So the first thing you need to do is graph the function in your y equals screen, the function that describes the situation. So in this case, that would be the function that describes the rocket's path. So if you have deleted out of your calculator already the equation that we used last time, then you'll want to go to your y equals screen on your calculator. So y equals screen, and you would want to type this in. Now your answer, if you're typing this in rather than pasting it like we did in the regression video, your answers are going to be just slightly different than mine because you typed them in rounded instead of pasting them. When you do a quiz or a test, it is expected that you paste them, which means that your answers in those cases will have the exact same answers as mine. So here in these notes, because you might have typed this in differently, your answer might be slightly off, but on quizzes and tests it should be the exact same thing. So that's our first step, is making sure we've got the function graphed in our y equals screen. The second step is to graph the specific y value that we want in another equation spot in our y equals screen. So I scroll down to my y2 in this case, and I type in the specific value that I want, which in this case was 300, since it's 300 meters. So then it says adjust the window if needed. Well, I shouldn't have to adjust my window because it's still adjusted to what I had it for the scatter plot. But if you've changed your window, then here it is. This window should work for us. So x is going from -1 to 20, counting by ones. The y is going from -100 to 500, counting by 50s. We never changed the rest of that stuff. So if you adjust your window to this, it should look pretty good. So then I can press graph, and you can see that I can see the parabola, which represents the rocket's path, and I can see y equals 300, which is telling me, this is where the rocket would have a height of 300. So in order to find the times, because in this case our x data represents time, our y data represents height. So I need to find the intersection points. Now notice, because this is a parabola, that there are actually two different answers, two different times when this parabola has a height of 300. So I'm going to go to second trace, choice 5 for intersect, and I'm going to put my cursor close to that first intersection. Now, if you want to find the second one first because it was closer, that's totally fine. I'm just going to do them in order. So I've got my little cursor close to the intersection, and then I'm going to press enter. Yes, that's my first equation. Yes, in red, that is my second equation. And yes, I want my calculator to guess, and it's going to spit out the answer. So what I want here is the x value only. I don't want an ordered pair because I'm answering a question that is when. When is the height? 300 meters. So one answer would be after about 4.2 seconds. So we could say after, and this squiggly equals means approximately. So it indicates that we've rounded. So after about 4.2 seconds would be one answer. Then we repeat the process, second trace choice 5, but this time I move the cursor closer to the second intersection so that it'll find that one. Sometimes a tedious process. There we go. So blue is my first equation, red is my second equation. Yes, I want you to guess. And that says 10.8. So after about 4.2 seconds and about 10.8 seconds would be our two answers. So that is how you find when your function has a specific y value. Now, the second thing I've listed here is to find a specific value for an equation that you've graphed. So this would be is if you want to find, let's say, so example would be find the height after 12 seconds. So this time, we know the x value as opposed to knowing the y value like we did in the first example. So I've typed this out specifically for this example. So it says, for instance, if you want to find a value when x equals 12, which is what I want right now, you have to make sure that your window goes past that value. So ours already does the way that I had originally adjusted it, went to 20. But this is a common problem that people have, is that they're trying to find when x is 12, but their x-axis, say, only goes up to 10. If that's the case, it's not going to allow you to do this process. So you always need to make sure that your x-axis goes at least a little bit past whatever x value you want to find. So your x max to find 12 needs to be at least 13. Ours is 20, so we're fine. So when we're given an x value as opposed to a y value, and I'm going to go ahead and delete out my y equals 300 because I don't need it anymore. But if I want to find when my graph, what its height is after 12 seconds, I'm going to go to second trace again. It's our favorite menu. But this time I'm going to choose choice 1 for value. And then I can just type in whatever x I want. So if I want to know when x is 12, which means time is 12, I type it in and it spits out the answer for me. So you can see I did a screenshot of this with a different window, but I've got 234.8 approximately. So that's what we would write down here. So about 234.8 meters would be our answer. Once you have the answer there, if you want to find multiple values, you actually don't have to start over like you do with second trace intersect. If I wanted to find when x is 15, I could just then type 15 and see how it automatically goes to the x equals, and then it's going to spit out the other value for me. So if I want to know 7, type in 7. If I want to know 8.5, type in 8.5. Whatever you want, it will find those y values for you. Okay, so that one's the easy one. So now we know how to find an x when we have a y. We know how to find a y when we have an x. The last thing we need to be able to find for this concept is to find an x-intercept, which are also called zeros. Zeros technically, by definition, are the x-coordinates of the x-intercepts. This one, step 1, is similar to what we had in the last process, but this time it's with the y-axis. in order to find x-intercepts, you have to make sure that your y-axis goes a little below 0. So I've always done this in everything I've shown you, just because it's good practice to always go a little below and a little above what you actually need. But if you look at our window, you can see that our y-min goes to negative 100. So it definitely goes below 0, so we're okay on that one. So step 2 then, once we have our window adjusted, is to go to second trace. Again, it's our favorite menu. And this time we're going to choose choice 2 for 0. Now, when it says left bound, and I've typed this all out here, it means that it wants me to tell it an x value that's to the left of the x-intercept I want to find. So it looks like this x-intercept is at 0. So you can do this one of 2 ways, and I'm going to show you both ways. You can either scroll, so move my little blinking cursor so that I can tell that my blinking cursor is to the left of the x value of the x-intercept. So I've done that, and I press enter. Notice that it puts in a dashed little line and a little arrow. On the older models, you only get the arrow, but this is just for your confirmation, because if that vertical line isn't to the left of the x-intercept, then you need to start over because you did it wrong. Now it says right bound, so that means, okay, move my blinking cursor so that it's to the right, x value wise, of the x-intercept, which this one would be. So press enter. Notice it puts in another line or another arrow. So your intercept should be between those 2 vertical lines or between those 2 arrows. If it's not, again, then you need to go back to the second trace menu and start over. But if it is, then press enter again to tell it to guess. And notice that it's going to spit out for you the 0. The y is always going to be 0 because it's an x-intercept. Y is 0. So in this case, we would say that x equals negative 0.11, perhaps. So in this case, we would write, oh, I already wrote it out down here. So x equals 0.11. And then we would find the other one. Now I'm going to show you the other method on this one. So go back to second trace, choice 2 for 0. This time I'm going to find this x-intercept, and certainly I could scroll if I wanted to, but you don't have to scroll. You can actually type in x values that you know are to the left or to the right. So my x-axis goes up to 20 right now, so 20, 19, 18, 17, 16. It looks like that x-intercept is at about 15, so I know that 14 should be to the left. So instead of scrolling your cursor, you can just type in a left-bound value, which you can see, yes, indeed, that is to the left, and then type in a right-bound value, so 16 would be to the right. Again, you always want to make sure that your x-intercept is actually between those vertical lines, which mine is, and then press enter. Now, this one is perfect because it illustrates for you something really, really important, and I typed that down in number 6. So sometimes, because your calculator is estimating, you'll get something something else, as your y coordinate. Guys, that is the same thing as 0, because what's that is saying is -7 times 10 to the -11th power. If you convert that scientific notation to a decimal, it's 0.00000, lots of zeros, and then 7. So this, anytime you see it, means the same thing as 0. Do not, under any circumstances, write this as a y coordinate anytime. That means the same thing as 0. You need to know that it means the same thing as 0. So I had x equals 0.11 over here. Now I have x equals 14.85. So x equals 14.85. These would be my 2 values. Now, what's the real life meaning of this? In this real life situation, this is the rocket's path, which means that the second x-intercept represents when the rocket would hit the ground because it represents when it has a height of 0. Well, at approximately 0 seconds and approximately 15 seconds, the rocket is on the ground. Here, it's because it's right before we've launched, or, right after it's pressed the button, but before it actually goes in the air. And here, that's when it comes back down and hits the ground. So really important that you know how to interpret that as well. Okay, that teaches you lots of major features of your calculator and how to solve them.